Hello friends, this is Anand Pai from Academy in Pursuit of Engineering Excellence. Today we will continue with the fluid mechanics. In that chapter 3, fluid kinematics, in that part 3 we will discuss what is steady and uniform flow. Okay. First, before that, let us see what is acceleration in an Eulerian framework, which we have discussed in the previous video. We are just having a recap of that. Now whenever we say Eulerian framework, we define basically velocity at every point, where velocity is made out of three scalar component, which is u, v and w. Okay. Similar way, acceleration, which is a derivative of velocity with respect to time, is also made up with three scalar component ax, ay and az. Here in this ax, ay and az, the part which varies with the time is called temporal acceleration, and the part which varies with space is called the convective acceleration. And this temporal acceleration plus convective acceleration is called the total acceleration. Okay. Now let us see what is steady flow. Now a steady flow is the one where velocity does not vary with the time. That is, velocity is not a function of time. In a steady flow, temporal acceleration component vanishes, and what remains is only the convective acceleration component. That means my temporal acceleration component with respect to time, the velocity variation with respect to time, is equal to 0. Let us understand this a bit further. Okay. So let us see how do we get this. Okay. Now if I have a flow field defined by the coordinates x and y. Now if I have a point 1 here, the velocity at this point, say it is v1. Now the velocity at any other point v2 may be different from v1, okay, and v3 might be different from v1, v2 and v3. v4 might be different from this. Okay, so magnitude and direction may be different for different point. The velocity, magnitude and direction may be different at different point in the flow field, but at every point in the flow field, the velocity does not change with the time. That means dou v1 by dou t is equal to 0. So it doesn't change with respect to time. That is what is meant by the steady flow. So if you say at time t, this is v1. After say t plus t, delta t you come, it is always v1. Any time it will come as v1 only. That is called a steady flow. Now let us see what is now a flow that is not steady is called unsteady flow. Okay, in unsteady flow it is a function of time. Okay, then it is called a steady flow. Let us see what is uniform flow. In a uniform flow, velocity is same on every point of the flow field. Okay, so velocity is not a function of x, y, z components. Okay, and in a uniform flow, the convective acceleration component vanishes. Okay, so u dou u by dou x, v dou v by dou y and w dou u by dou z, which is a convective part of ax, it vanishes. You see here this goes to 0. And the flow which is not uniform is called non-uniform flow. Now let us understand this further. Okay, now if you have to have a non-uniform flow goes like this. Say this is x and y. Okay, sorry, not non-uniform flow, uniform flow. If we say uniform flow, if I have at point 1 v1, then at any other point in the space the velocity should be same as v2. At any other point, say this is 2, this is 3, v3, it should be same as v1. So what is happening here? v1 should be equal to v2, it should be equal to v3. All are vectors, keep in mind. Okay, so this, if it is there, then only it is a uniform flow. Otherwise it is non-uniform flow. I hope you get the concept, students. So wherever velocity varies with time, wherever the velocity does not vary with time is called steady flow. The one which does not vary with space is called the uniform flow. And in case of steady flow, the temporal acceleration vanishes. In case of uniform flow, the convective acceleration component vanishes. There is a question which has come in GATE 2014, which says that a flow field which has only convective acceleration is What is the answer, students? The answer here is C, which is a steady and non-uniform flow. Since it has a convective acceleration component, it has to be non-uniform, and has only convective acceleration means the temporal acceleration is 0. That means it is a steady flow. So students, I hope you have understood whatever we have discussed till now. If you have further doubts, you can kindly mention those doubts in the comments. I will be more than happy to answer those. And kindly subscribe to my channel and click the bell icon so that you could get further notification. Thank you very much, students.